Since this class is about global warming, the key fact we have to establish, that is the key measurement of the material world we need to make, done with the best available tools, vetted by skeptical peer review, and preferably independently reproduced, is the global temperature. The global temperature doesn't mean much to you per se, because what matters to you is the temperature where you live. It depends on the day or night, it depends on the seasons, and it depends how far from the equator you reside, at what latitude you are found. But we want to establish something about the global climate here, and so we need to measure the global temperature and average over day and night, over the seasons, and over the latitudes, over the land, over the ocean. We want a number that characterizes the temperature of our planet. I have a series of maps here that show you how that temperature has evolved over the last 140 years. So the first is a map of the world and its temperature departure from the average of temperatures in 1951 to 1980. We'll take that 30-year period as our reference point. In 1888, the globe was, for the most part, colder. As you see at the bottom of the diagram, there's a little bar. The blue colors mean the Earth is cooler. The warm yellow and orange colors mean the Earth is warmer. So in 1888, compared to the 1951 to 1980 average, we see that much of the world was cooler. There's a little bit of Alaska and a little bit of West Africa that was slightly warmer than that average period. But for the most part, the continents and even some of the oceans were cooler by about 1 to 2 degrees Fahrenheit than the temperature in 1950 to 1980. Here's the map in 1968. Now, 1968 falls exactly in the middle of that reference period, 1951 to 1980, and so as you would expect, the Earth's temperature was about that average. In 1968, we see there are no departures by more than 1 degree from the warmest places to the coolest places. The mean temperature for the whole globe was 13.9 degrees centigrade, or 57 degrees Fahrenheit. If I step forward, however, we see what happens. 1978, a decade on, we see that Canada and much of Eurasia is slightly warmer by almost a degree than that earlier average. If I go to 1988, much of the Earth is warmer. There's still a few cool spots, but in fact, we're now looking at temperatures over Canada that are a couple degrees above that long-term average. What about 1998? Things continue to get warmer still, and we see that over the northern hemisphere, the temperatures are up 2 to 3 degrees above average, and even the oceans have all warmed above the 1951 to 1980 period. If we go to 2008, we see this trend is even more pronounced. All across the Arctic regions and down into much of Asia and North America, we see the temperature is 3 to 4 degrees higher, and the entire Earth is warmer everywhere. And finally, to 2018, the Earth has warmed up by 0.9 of a degree centigrade, 1.7 degrees Fahrenheit, to 58.7 degrees Fahrenheit, or 14.8 degrees centigrade. And you see it's not evenly distributed. The oceans are warmer, but only by about a degree, because water takes a lot of energy to heat it up. But the land areas, particularly in the northern hemisphere, are considerably warmer by up to 4 degrees and even more. Let's look at what this looks like on a year-by-year basis. Here's a plot over my lifetime from 1950 to 2015. And what it shows is the average temperature compared to this 1951 to 1980 average. Note I've indicated here where Wally Broker's paper falls in 1975 that predicts a pronounced global warming. The color bars here represent a phenomenon called the El Niño Southern Oscillation. It's a result of ocean currents in the eastern Pacific in alternate years, making the temperature warm in the eastern Pacific and making the temperature colder in the eastern Pacific. This was recognized from ancient times, long before Europeans came to North and South America, because it changes the fishing prospects off South America considerably. The conquistadors, because this usually showed up around Christmas time, named the warm period El Niño and the cold period La Niña, El Niño being for the little baby, and in most years, it's sort of a neutral wash. So you see the red points there when there's a warm pool of water over the eastern Pacific tends to mean the whole globe is slightly warmer, but it's not a direct correlation. But let's look what happens. From 1950 to 1975, Wally Broker's paper, the temperature fluctuates by 1/10 of a degree or so, up or down. It's about equal to that long-term average. But then, starting in 1977, for 45 years in a row, the temperature continues to rise. Now you may have heard that, oh well, yeah, back in the 80s and 90s the temperature was rising, but in fact, then the temperature is flattened out and not much changed. Well, it's true that if you cover up most of the graph, you can see that the period 1997 to 2012 was relatively constant. If you take away the 2 El Nino years, which are anomalously high as usual, you see that actually 97, 98, 99 were lower than 2010, 2011, 2012, but you could fit a straight line to that part of the data. However, it's always a bad idea to throw away most of your data. And using exactly the same data and uncovering it, I do this fit to the curve, which looks just as good to me. That is a steady rise in the temperature of 0.14 degrees centigrade per decade over this entire 45-year period. Now that was up until 2015. What happened next? I don't know if you remember the winter of 2016, but I remember it because in New York, I was having a barbecue at 70 degrees on Christmas Eve. 2016 was strikingly warm. The winter temperature in the US averaged nearly 5 degrees above the 20th century average. February in New York City was nearly 9 degrees above the long-term average. And if we take the whole winter of 2015 to 2016, we see the entire United States was above average by as much as 10 degrees. Indeed, January of that year was the second warmest month ever recorded on Earth for the entire globe, even though it was winter in the Northern Hemisphere. And February was the warmest month ever. So 2016 really took it up another factor until we're a full degree centigrade, 0.99 to be precise, above the 1950 to 1980 average, or 1.8 degrees Fahrenheit, above average for the entire globe. Now, it was an El Nino year, and you might say, what happens next? So next we have another 5 or 6 years, and in fact, all of them are not only above average, they're above that long-term trend, and 2020 tied 2016 as the warmest year on record.